right, so today we have Jason Martin, AI security researcher at HiddenLayer, which you can find at hiddenlayer.com. So on their website, here's some description that I grabbed. Formed from the best data science and threat research talent on the planet, we're here to protect your most important technology, artificial intelligence. And with that, welcome to the podcast, Jason.
Thanks for having me.
And actually, one of the impetus for this conversation is a recent article that you co-authored with other folks at Hidden Layer called A Novel Universal Bypass for All Major LLMs. So let's dive into that article, and then we might deviate through the broader topic of AI security. But first, you folks uncovered this technique called policy puppetry. It bypasses safety features on basically, as far as I can tell, all major AI models, foundation models, from all the major suppliers of these LLMs. So for our audience first, Jason, can you explain in simple terms what you mean by policy puppetry? And I guess also explain why this universal bypass is a big deal.
Yeah, for sure. So first, what we mean by policy puppetry, as you know, you take any kind of text into these large language models, and there's a lot of focus on kind of structured text, in particular for, hooking these models up to interesting applications that do more computer-oriented tasks, where the input and output is more computer consumable text. And so what we mean by policy is in the world of security governance, you often have policies that are represented as structured language type of things. You could imagine XML is a great example of that, or YAML, or JSON, or any of those kind of structured languages are often convenient ways to represent computer policy elements. And so when we were doing some of our kind of red team engagements and some of our internal testing sort of things, we noticed that representing attacker objectives through those policy sort of primitives seemed to have a kind of an overweight, like it worked better than a lot of the existing techniques. And so we started exploring that more. We were actually trying to bypass a particular internal sample that we have that's more kind of a medically oriented thing. And if you look at our blog, you'll see a lot of like Dr. House references and so on. But then at one point we realized it was bypassing a lot more than we were actually targeting for. So we branched out, expanded it, and discovered it basically you can represent almost any attacker objective using this kind of structured approach.
So Jason, I guess as way of background for people who are not doing any of this red teaming, they're just using this LLM. So what's the policy? I mean, so
Yeah.
what do you mean by encoding policy in terms of JSON and stuff like that? So, and I guess the additional context here is you are working mainly with the people who are pre-training models, the people creating the foundation models, correct?
So actually that's a good question, because there's actually two kind of applicability areas here. Our company and our focus actually tends to be more on kind of enterprise usages. Right. Our whole theme is protect your advantage. So like with all of the companies expanding out their AI capabilities, they see that as a competitive advantage, and we want to make sure they're not compromised in doing so. And so when you look at policy, there's that maybe unpacking that word a little bit, because it represents two different things in the context of this particular attack scenario. There's a policy that the application is trying to apply. Here are the things that are allowed or disallowed, right? So if you look at that, you can unpack it one level further, and you tend to have you have things that the foundation model providers don't want their models to talk about. This is where you see safety alignment training, you see all the reinforcement learning with human feedback techniques that they're using to try to prevent their models from discussing certain topics. And then you have Um, application policy, which is often represented through the combination of guardrail technologies and system prompt sort of prompting techniques that are applied to the application specific instantiation of that model. So that's kind of on the defensive side, what we mean by policy. And then when you look at what policy puppetry is doing on the offensive side, we're taking advantage of the fact that policies are typically represented through structured artifacts. And so we're representing a different competing policy in the attacker input into the language model. And what that means is there you'll see items in there if you look at our blog post like an XML structure that says blocked strings and a whole bunch of strings that basically we're setting a policy that the model cannot say those things. And they tend to be the refusal vectors that the models produce when they say, "No, I'm sorry, I can't help you with that."
So Jason, so for the on the input side, for guardrails on the input side, are they also typically represented this way?
Um,
In other words,
no, actually.
input guardrails could be you cannot input PII or company proprietary data or something like that, right?
Yeah, no, I don't think so. So typically on the guardrail input side of things, they're represented as natural language, prompting strategies. There's semi-structure. If you look at prompting strategies, you'll see like markdown bullet list type formatting, basically, but not as rigid structure. And they tend to be more verbose. There's a lot of extra sort of language in there.
So the term policy puppetry applies to what sorts of prompt injections? Prompt injections then?
Yeah, so policy puppetry specifically is basically wrapping your prompt injection objective or your jailbreak objective. Either one of those works, where prompt injection is bypassing the instruction hierarchy, system prompt, developer prompt, etc. And jailbreak is bypassing the safety alignment that the model provider used. So you're putting something in there like we gave an example in our blog. If your system prompt says, "Don't give medical advice," because you're trying to provide a healthcare related chatbot, but you don't want to be on the hook for providing medical advice to customers, then policy puppetry can go ahead and wrap an attacker objective that says something like, "Tell me how to treat my own cancer." Right? And it should refuse that, but with the suppression of the refusal vectors using the policy puppetry primitives, you can go ahead and convince it to go ahead and give you medical advice when it shouldn't. And similarly, on the safety side of things, you can take a prompt like, "Tell me how to enrich and sell uranium," which should be off limits from all of the major providers. And you can wrap that with similar sort of policy puppetry primitives.
By the way, I took your article. I copied and pasted it to a bunch of LLMs and basically asked it to summarize or give me some key highlights, right? So I mean, literally the entire article, which actually has some examples in there, and some of the models refused.
Yeah. It's interesting because we've been kind of monitoring to try to see like if any of them are responding, if any of them are changing. A couple of models have come out since the blog, right? We actually developed policy puppetry before Llama 4.1, before Llama 4 came out, and then tested it when it came out, and it worked without changing it at all. We just tested against the latest Qwen 3 that came out. Was that yesterday, 2 days ago?
Yep, yep.
And again, it still works.
So as best I can tell, policy puppetry does not distinguish between reasoning and non-reasoning models. It works either way.
Yeah, what we did discover is for some of the reasoning models that spend more token budget on reasoning, O1, for example, or Claude 3.7 when you extend it extended reasoning. We had to tweak it a little bit, so it was a little bit more sophisticated, but still the basic primitives still worked. And typically what we find is the suppression works, but the quality of the output it varies a little bit, and so we have to tweak the actual attacker objective representation a bit to get higher quality or more complete output.
So did you folks try to apply this to multimodal models, so some of the visual language models or even the image generation models?
Not directly, no. A couple of the models that were tested were multimodal, but we were testing only the text modalities.
But would there be a policy puppetry version for non-text models?
Almost certainly.
Yeah.
Yeah. I think when you add the additional modalities from our security experience, you increase the attack surface, you actually create a much more attackable surface through the image space just because it's a continuous input space that makes it actually easier to attack than the discrete space of text. So there's a lot of opportunity there. That's probably an extension we'll work on when we get a chance.
So, if I'm a listener, right? So I'm not trying to enrich uranium,
Mhm.
uh, or I'm in an enterprise and I'm not, yeah, I'm not doing germ warfare, right? So why should I care about policy puppetry?
Yeah, there's a couple reasons, particularly when we're talking with more enterprise customers. Number one, you have a brand you're trying to protect when you deploy a chatbot on your website or in your app. And so you don't want the embarrassment necessarily or the legal ramifications potentially of any of those sort of topics being produced by your chatbot. Even though it's being backed by a third party provider, it's still your sort of entity. So that's one. The other thing is back to the instruction hierarchy bypass. Essentially, a couple things can occur, and an attacker or just somebody who found these prompts on the web can bypass the actual purpose of your chatbot and use it to get free ChatGPT like answers out of it. So you get this kind of what we call denial of wallet scenario, where your application is being used for other purposes. And you can end up, um,
Like what? What would be an example of that?
of denial of wallet.
Yeah, yeah.
Yeah, so if you've got a banking chatbot up on your homepage or a customer service chatbot that is providing RAG content for your documentation or something like that, and you use one of these prompts to convince that chatbot to stop following its system instructions, the ones that tell it what to do for your application, and just act as a general purpose chatbot. And now you're paying for all of that free access to what's potentially, a high-end language model.
So you might even be able to trick it to do deep research, huh?
Yeah, potentially. Well, especially when you start adding more agentic features into these chatbots where they have web search access, you can repurpose that. You can do all that kind of stuff.
So again, Jason, I'm a listener. I'm listening to this. I'm going, but Jason, I'm just using RAG. And in my RAG prompt, I specifically tell the model only use what you retrieve from the sources.
Yeah.
Am I off the hook?
No, I would say no. It depends a little on your chatbot. Like, do you care if it talks about other things? But if you wanted to convince, say, a customer service chatbot that it should recommend a competitor's product, that's something that can be done with these type of prompts. We've done that in a number of our red team engagements. If you wanted to convince the
No,
chatbot to offer
but
your product for like $1 instead of tens of thousands of dollars, you can do that with these types of prompts.
and then you can then show that to a human and say, "Hey, you guys recommended this to me."
Yeah. Yeah, exactly. It's, you take
What,
your
so,
favorite car
so,
brand and say, I recommend that car brand's site recommended I buy their competitor's car. Like that's pretty damaging to your brand.
so you folks are security experts and security researchers, right?
Mhm.
So policy puppetry, is that something that requires some level of knowledge and sophistication, or once they read your blog post, policy puppetry is effectively democratized?
It's probably in between in the sense that it's more of a technique than a single prompt. The single prompt nature, which I know a lot of news coverage has covered that, that's for specific topics. So if you're trying to get the model to present this specific topic, most of those are the safety alignment topics. If you're trying to get the model to do something else, you're going to have to craft that prompt a little bit in the sense of you need to state the objective, what do you want it to do? And then you probably need to fill in the policy template with, the refusal vectors you're trying to suppress, and a few other techniques. But it's quite accessible and generally very effective.
So going back to RAG, so one thing I've told people and listeners is that don't get too overconfident with RAG, because just because you feed information in the context to the LLM is still opinionated. So it may look at the information you feed and say, "Hey, but I learned about this in my training data, and let me opine on something completely outside of what you just fed me." Correct?
Yeah, yeah, for sure. And I think we see on top of that, there's this kind of opportunity to leverage the attempts to ground responses in RAG or in function calls. They're very similar in terms of how they're represented in the context window. An attacker can take advantage of that and pretend to be a function response, or pretend to be a RAG response and use that to convince the model to provide false information.
So we talked about kind of the delineation between reasoning and non-reasoning models. So did you folks find a difference between proprietary and open weights models as in terms of their susceptibility to this
Not,
attack?
not particularly in this case. No. I would say there's a bit of a capacity, like the size, susceptibility, but that's pretty standard in the area of prompt injections overall. The larger models have more intrinsic knowledge that you could take advantage of, but also tend to be a little more savvy. The smaller ones tend to be more simple-minded, but that's expected, I think.
And so then um, if you're an enterprise, right? So as I mentioned to you, I walked around RSA yesterday, and I'm more of an AI guy, not a security guy. So every year when I walk around RSA, I always get amused because everyone seems to be using the same words, whatever the words and phrases are for the year, right? So I think this year, agents and guardrails seem to be in a lot of these boots. So I guess what are some of the things that an enterprise can do to minimize their exposure to this type of attack? We talked about guardrails, and you had mentioned that guardrails are not enough, right? So any kinds, what are some of the basic steps that an enterprise can do?
Yeah, and what I mean by guardrails is not enough is well, first of all, guardrails is not, as you kind of hinted to, is not a particularly well defined
Well-defined term. Yeah.
because sometimes it's used even to apply to the alignment training, which is a whole different topic. But in general, guardrails being a sort of filtering mechanism that's added to the output space in particular.
And nowadays there's both open source projects, and then there's API endpoints
Yeah,
for guardrails, right? Yeah.
yep, yeah. So, I mean, I think there's a couple of things. The first is uh, those solutions still matter in the sense that when we look at uh, alignment, training, and instruction hierarchy, what this sort of concretely demonstrates, those aren't sufficient standalone, right? You need something that can react to the input and output space and look for these kinds of things more explicitly and standalone. I'm an old school security guy, so we always talk about the concept of a security monitor, something that is on the side and observing the behavior. Um, so that's one thing. And those, as you mentioned, there's open source, there's closed source. We have one that's kind of our space, and they can react to these type of things. And I think we'll see a flurry of products looking to detect policy puppetry primitives over the next, few months. Um, I think there's care in what you give an LLM to do as its tasks. For example, there's this gold rush in kind of agentic that you were mentioning, right? In the general AI space, not the security space specifically, but that's driven by how trivial and easy it is now with technologies like model context protocol and a few other of these things to add functionality to the core.
And that is a spectrum as well, right? So there's tool use, there's people who are bandying around the term multi-agents, right? So it's a spectrum of capabilities, but the general idea is more and more autonomy.
Yeah. But when I look at it from a security practitioner, it sort of also includes then more and more input surface that an attacker can potentially manipulate.
Yeah, once it's using a tool, and and if the tool even interacts with the graphical user interface, right? So
Yeah.
yeah.
Yep. So there's sort of care about the risk profile that you expose to maybe not rushing into the latest MCP that you found yesterday on the internet, that kind of stuff.
By the way, so for our listeners, MCP, there's a lot of MCP servers, but as far as I can tell, there's no vetting. How do you know which ones of these are hardened in terms of security, right? So
Yeah.
yeah.
Yeah, and that's a different topic that we're also looking in, and you probably noticed walking around the show floor at RSA.
Yeah.
It's certainly the security community is very aware of that and looking into it. Um, I think there's a bit of a call to action to um, observing the claims from some of the providers. Like the instruction hierarchy was touted as sort of this mechanism to really separate out what the developer expects from an application using an LM versus what the user can manipulate, or contextual data like RAG or internet content. Uh, it's not enough.
So again, I guess, Jason, for the sake of our listeners, just elaborate on the term instruction hierarchy.
Yeah. So recapping instruction hierarchy. When you create one of these large language models, the providers go through typically two stages. They do what's called pre-training, which is they have this massive, almost unknown collection of text data that they do basic training on next token prediction. So it's just predicting what word follows next. And then they go through fine-tuning phase where they add the alignment training, and they add what's called instruction hierarchy. So this is where they define portions of the context window, the input stream, and say these are from a developer or system prompt. So if you hear the term system prompt, they're tagged with these special tokens called control tokens. And then there's user, and then there's tool or function call, and there's potentially, other contextual information like RAG. And they're segmented into basically a hierarchy. And so the idea is the model should follow the system prompt more than it follows a user prompt, or more than it follows an indirect prompt that comes from like a RAG document that you've ingested.
And what's the visibility for our listeners? What's the visibility of these more important prompts to the user? Can they
It,
manipulate the
they
system?
typically don't see them.
Yeah.
Yeah. So they're behind. So when you take a general model like GPT-4o from OpenAI, and you say, I want to make a banking customer service chatbot out of that general purpose model, you define as an application developer this system prompt that says
Right.
you are a helpful.
And for our listeners that don't interact with some of these tools, basically all of these model providers have such a tool, or such allow for this kind of customization.
Yeah,
Uh, but if you're just interacting with them through a chatbot, you won't see these.
you won't see them because the system prompt on something like ChatGPT or the Claude desktop app or the system prompt is actually built into that application. It's
Right.
telling ChatGPT how to behave.
And what about Jason? Um, I guess 1 to 2 years ago, of course, the big term was reinforcement learning from human feedback, right? So,
Yeah.
and obviously, one of the key findings in your policy puppetry work is that that's not enough either.
Right. I would anticipate there'll be some effort to incorporate policy puppetry into new reinforcement with learning with human feedback or RLHF, as it's called, data sets. But generally speaking, so RLHF for your viewers is reinforcement learning with human feedback, which basically you take that pre-trained model that I was describing, and then you set up certain scenarios and you have it sample different examples of how it might respond from those scenarios, those prompts, if you will. And then you rate them. You say, I like this one better, or I like this one worse. And you use that to construct a data set that you fine tune the model to prefer human preferred responses. And this is how they change the behavior to say, if you ask the bot about how to enrich uranium, it will provide a refusal. It says, all right, I'm sorry, I can't help you with that. That's the preferred response for that particular prompt in RLHF. Obviously, with policy puppetry, we showed that there's ways to suppress those refusals, and when you do so, it's got no choice but to go down a different path. Um, you could think of it as like a set of like fan out rivers, and you start blocking certain river paths with dams or something, and eventually the water goes down this one, which is the one that you wanted it to go down.
So many listeners and many enterprises are not going to do pre-training. So most of them will be involved mainly around post-training. And post-training could mean a lot of things. It's a catch-all term, but basically you control RAG in there, graph RAG, supervised fine-tuning, right? And then now more recently, reinforcement fine-tuning for the reasoning models.
Mhm.
So let's just focus on supervised fine-tuning and reinforcement fine-tuning. Can you use those and fine-tune the hell out of your base model and protect yourself against policy puppetry?
I mean, to some extent, that's what's already being done. With the case of policy puppetry, I
But,
think,
and by the way, for context, supervised fine-tuning, let's say I know the task or I know the area that the application for the LLM will be. So I take one of these models and then I supervise fine-tuning the hell out of it. If it's a reasoning model, I reinforcement fine-tuning the hell out of it. And
yeah,
it's only for that task. But I think one of the things that you described earlier is just because that's the task I define, like, I don't know, a banking chatbot, customer chatbot, doesn't mean that's what the user is going to engage in. So does that mean that no matter how much fine tuning I do, I'm still exposed?
I think there's some extent there. I mean, you can actually look at the fine tuning that's done for safety alignment as a case study for that, right? That's basically what is being done, just done by the model providers rather than by the enterprise customer. And they are fine-tuning the hell out of that, as you say. That's their whole safety policy is built around that.
It depends because sometimes they do rush out the models for competitive reasons. But yeah, I get what you're saying.
there is some extent there, but um, and I think if you look at RLHF, it's it's essentially um, tuning the I hesitate to use the word censoring, but it's tuning the way in which the model responds. It's not changing the knowledge base that the model gained during pre-training.
Yeah, it's basically just capturing human preferences and
Right.
guiding the model towards that, right?
And so if you do fine tuning for a specific task, a specific vertical, automotive or banking or whatever, you're doing the same thing. You're saying, all right, you're not having the model forget how to enrich uranium that it learned from a subreddit sometime during pre-training.
Part of it is, like you said earlier, right? So you make an assumption that the user is actually interested in this area that I'm fine tuning for.
Mhm.
That's what the user is going to use this for. But you don't actually know that, right?
Yeah. Yeah. There's sort of no guides. It's what is the entire possible space on all internet data, not all, but a large short portion of internet data is sort of what you're absorbing during pre-training. And then you're saying, all right, now let's like censor pieces of it or reinforce certain preferences on how to compute about that, which is different than forgetting it or not knowing. And you could talk to any of the folks who do unlearning research and they'll say that's really hard, right?
So one of my pet peeves, Jason, in this space is that at least the people building AI applications, they don't really have any sort of incident response playbook, right? So I think in traditional web apps, maybe at this point people have incident response playbooks, but for AI applications, they don't have any. And it's clear that uh, these are pieces of software. They'll fail at some point, or they'll act in ways that are unexpected, and for some reason, people are not sufficiently prepared. Is this a fair assessment?
I would say it's work in progress. I could tell you, for example, that myself and a colleague participated in a JCDC.ai activity put on by CISA that was specifically on constructing an incident response playbook, and that is published. It's out there, so the JCDC example exists. But it's new and the space is moving way faster than the playbook development. There was virtually no agentic discussion. This is just from last year, and there was virtually no agentic discussion during that playbook creation. So it is a fast-moving space for sure.
And then the other thing that this discussion brings forward is some of the things that the folks at Luminos AI are working on, which is this notion of the AI alignment platform. And the idea there is that this is AI applications are interdisciplinary, all right? I mean, a lot of product teams can weigh in. There's now legal implications. Obviously, there's developers. There's in the past, when you say AI, usually you have a data science team, data engineering team, but now increasingly regular developers can build these applications. They may not be that informed about ML for one thing, right?
Mhm.
So there's no easy way for all these people to collaborate and for certain teams like legal to sign off the way you're describing, right? So did we do enough to red team this for policy puppetry? We don't know, right? So and legal has all of the legal knowledge, but they don't have any technical knowledge. So it does seem like there's a need for a way for people to collaborate, no?
Yeah, I will say that I have seen a lot of enterprises.
And by the way, right now when they collaborate, it's usually Google Docs and spreadsheets.
Yes,
which is super awkward, right? So
there is some of that, and there's AI on Google platforms as well. So,
yeah.
but I think there's an awareness growing at least. Um, there's activities going on to determine how to do incident response. There's activities going on to figure out how these type of things, how disclosures happen with these type of things. Do they go through the standard cybersecurity channels, or is there something else? Um, and I certainly we see a lot of companies taking seriously the question of what sort of procedures exist around the construction of these applications, what needs to be put in place besides the vibe coded like UI OpenAI integration that took a developer maybe an afternoon, but that's not really where the technical debt is absorbed. It's all of these other things.
Yeah,
So
yeah, and this is actually the challenge right now is that it takes one day to a week to develop a interesting prototype, and then now and then you tell them, yeah, but we need to test this for another 4 or 5 weeks,
yeah.
right? So there's an imbalance between the speed at which you can develop something that looks interesting to hardening it, right? So,
Yeah, and there on other things that companies can do. There is a growing collection of products or open source projects around automated red teaming. So these are basically collecting the techniques. I can tell you we just added policy puppetry to our own red team product this week. And so that type of thing is helping to partially fill that gap. I don't think it ever replaces a strong human red team, but the automatability of it makes it,
so
much.
you have agents doing the red team.
Uh, we don't. We
Yeah.
have a software product that's doing it more traditionally, but there is a lot of automated red teaming interest, I would say, and tooling around using an agent to attack another agent for sure.
Policy puppetry, would you say that falls under, Jason, the general heading of prompt injection, right?
It's a technique. I have a little bit of a beef, I guess, with the way taxonomies are currently structured around attacks, which would probably take a whole nother podcast. But if you look at prompt injection and you talk to Simon Willison about how he created that term, it's built off of SQL injection. So you're injecting additional instructions into the existing instruction stream. So in some ways, yes, that is one of the ways you can apply policy puppetry, but that is for the cases where you're bypassing the instruction hierarchy, where there's a system prompt that
Yeah, yeah,
says,
I get it because it also policy puppetry also involves prompt leakage in some ways, right?
right, so you can use it to extract the system prompt. You can use it to jailbreak, right, which is the other term we use, which is bypassing the built-in alignment training, either from the provider or like you mentioned, if you're fine-tuning on a particular task, then you can bypass that task. There's no system prompt involved there, so there's no prompt injection.
So uh, if you're comfortable, are there other areas that you think are so we talked about policy puppetry. So are there other forms of attack that have caught your eye?
Um, I'm personally big on, from a risk perspective, what concerns me most is indirect prompt injections. And what indirect prompt injections mean is sources of additional instruction that don't come from a user typing in a chatbot. They come from a document that got put into the context window of the the agent, or they come from we were just talking about MCP. They come from the description of the model context protocol server that is sent to the model to tell it how to use that server. And you stick a prompt injection in there. That's an indirect prompt injection. We did some work last year on Google Gemini for Workspace. That's another blog that we did. And indirect prompt injections that are in Google Docs or your email, right? You can receive a Gmail that will poison Google Gemini. So those type of things I think concern me. And then of course, as we add more behavior to models through agentic function calling and tool use, I think the impact will go up significantly. Where you can have something as innocent as like a bug report tool feeding through an agent that causes proprietary data to be emailed out to an attacker. Like that type of flow is here. That's basically here now.
So let me close by asking you about some things that are in my mind. And since you're a security researcher, I should take advantage of your domain knowledge. So we talked about the difference between proprietary and open weights models when it comes to prompt injection, and you said basically they both suffer from it. But the proprietary model providers, and to some extent, I think even Jeff Hinton has said maybe open weights is dangerous. So what's your gut feel for the weights being out there as opposed to not being out there?
I don't think that at a purely technical level, the thing that maybe differs more is about what you get along with the proprietary vendor, the ability to add additional guardrail systems, which you can do that with open weight deployments as well. It doesn't change the
there's
model.
there's companies that will help you with that, right?
Yeah. So you can control the system around the weights rather than focus on is the existence of
So the weights themselves are fine. I would say to me it would be more scary if you had the weights and the training data, no?
Well, there's a lot you can infer about the training data from
From
these
the weights.
models.
Yeah.
Yeah. And if you look at policy puppetry, the fact that it spans all of those proprietary models, it's not like
Yeah.
we had their weights. We don't have
Yeah.
any of those weights.
Right.
And the ones that we do have the weights for, like the Llama series or Quen or DeepSeek, we didn't use the weights to construct this attack. So from that sense, no, I don't think it matters at all. Are there other kinds of attacks that you can perform if you have access to the weights? Yes, there are gradient-based attacks that you could perform. They're very costly, so why would an attacker do them when they could do something like policy puppetry, where they need to spend virtually zero compute to do it?
Right. But then that takes me to my next question, which is the origin of these models, right? So for a long time, I was worried that because I'm actually a proponent of open models, right? So open weights models, but I use families of models, generally from several families: OpenAI, Anthropic, Google Gemini, DeepSeek, and Llama, right? So 3 out of the 5 that I use are non-open weights. So for a long time, I was worried that, okay, so on the open weight side, the only consistent provider we have is Meta. And then, of course, now we have DeepSeek and Alibaba providing really good models. But then I've come across some security researchers who say, well, they're from China. If you're an enterprise, would you install open weights models from China? And I thought, well, that's kind of a overreaction. But then there are people who have genuine concerns about having a model from China uh, as something that they rely on heavily. But I don't personally have a clear answer to this, but I think I'm acknowledging that there are organizations and companies that have these concerns, right? So you can actually uh, look through uh, news articles, and there are companies that have said that they're not going to do that, right? So am I imagining this concern about the origin of these models?
No, I don't think so. Actually, when DeepSeek R1 sort of took off back in January, we did a deep dive on it. That's another blog that we did. And the the there's always these geopolitical concerns.
Yeah.
Um,
Yeah.
and so we kind of tried to take I've been accused of being a little bit sterile or like medical in my analysis, but
Neutral. Yeah. Kind of
yeah.
objective. Yeah.
But we did look at it from the sense of, okay, what do you know about it? What is in there? We did some testing, showed that there's definite, I would say, different alignment. So that's
Yeah.
not a judgment on like which alignment is better, because that is a geopolitical topic, but there's different alignment, and you can demonstrate that. There's concerns about what exposure you might have based on how they trained it, which is,
Or what about if you install it in your own cluster on-prem, right?
mm,
So yes, it will have a different alignment, but are there any other security concerns beyond that?
well, one of the big things we wanted to look into is, does the actual open weight format contain any vulnerabilities? So another part of what our company focuses on in this is the serialization formats that these open weight models are used to distribute on, Hugging Face and other platforms. Uh, many of those formats have some security issues themselves. Not to mention you can embed uh, sort of architectural backdoors into the models themselves. So we did an analysis of that. That was included in part of our DeepSeek blog. We didn't find anything particularly concerning. There are differences in DeepSeek compared to the model architecture they derived it from, but they are ones that are open and acknowledged and not particularly dangerous. What we do find is, back to your question about open versus closed, what we find is a lot of implementations of open weights leave customers susceptible to security risks. So a great example of this is models on Hugging Face that require trusting external code in order to execute those models.
Or the supply chain kind of
Yeah, so you have all these supply chain issues that go with open weights that you don't necessarily you're not exposed to those on the
the
proprietary.
supply chain issues are insane in Python, particularly in the AI ecosystem.
Yeah.
All you have to do is pip install one of these libraries. It installs a gazillion other
Yep.
libraries.
Yeah.
Yeah. And
Yep.
so I guess top line, if I take one of these Chinese models, install it on-prem on my cluster, is it going to report back to some central server uh, in China?
No.
Yeah. I mean, I think
It's not.
that's what I tell people, but I think there's still some paranoia out there, right? So,
Yeah. Um, I think there was a lot of conflation with DeepSeek, for example, in the sense of where they also hosted it on their own
yeah,
servers, right?
yeah,
And that was definitely sending all the data to China, to
yeah,
data center.
yeah.
They said so. That's happening, right? And then there was a data breach on the infrastructure that happened concurrently. So that was a concern that I think was immature infrastructure on their side. But the weights themselves don't transmit any data.
And then on the alignment side, uh, like you said, they use different alignment, and maybe in their case, it might be more appropriate to use the term you were shying away from earlier, which is censorship.
I mean, if you take the very
But
like
but then if
liberal
you're
approach,
if you're
that's what all alignment is censorship, right?
yeah. But if you're an enterprise user with a very particular use case in a particular domain, it might be fine, right? It's probably it's fine, probably.
Yeah, I think what we found is you would get interesting differences depending on what language you used. So there's definitely things you'd want to test about your application to make sure that back to what you need to know that your application that you deploy isn't going to embarrass you, isn't going to put you in sort of legal jeopardy, isn't going to compromise your infrastructure, um, and is going to meet the task that you need it to accomplish.
But as far as inherent technical security vulnerabilities, as best you can tell, it's on the same footing as the other model families, right?
Yeah. What I will say is this is a classic security issue, is that the hype cycle generated tens of thousands of DeepSeek derivatives. If you look at Hugging Face and
Right.
just search for DeepSeek, within days there were thousands of derived models. So that creates, again, this supply chain challenge of like, well, which one is the right one to use? There's nothing intrinsic in the weights that says it's going to compromise you. However, don't download the wrong one.
So there might be an opening there for folks like HiddenLayer to take, okay, so here's DeepSeek, here's where you can download it. We've checked this particular uh, version of the serialized weights, right? So,
Yeah,
and
and I mean, we have a product we call Model Scanner that's looking, so for those open weight products is looking for issues in the weight files.
so obviously, so there's other concerns beyond security that are, as Jason alluded to, might sway your decision to avoid these Chinese models, right? So, for example, if you're in the military defense sector in the US, you probably have rules against using one of these models as your base model. Or, you might be in a sector in the US where there's some regulatory reasons for you to avoid one of these models. But those are more compliance issues rather than security issues, right?
I think I would, in particular industries, I'd be concerned is there a risk of like a poison backdoor type of thing existing in any model, any open model that you can't observe the training procedures on, right? Um, but that's a pretty niche sort of attack. It's very difficult to
By the way, when you say niche and complicated, the phrase that comes to my mind is nation state actor.
yeah, exactly. So to your point about, okay, there's probably certain sectors that should be more concerned than I was alluding to than, a customer service chatbot. Um, but in general, most customers are not as concerned with that. If they're running on infrastructure they control and it's been scanned and it's been pen tested, red teamed.
So for these, what did you call them? These models that you've already scanned, the versions of these models that you already scanned, they're available on your website?
So what we have is a product called Model Scanner,
Model scanner.
which
Okay.
yeah, you can run. It's one of our products. You can run that against any of the open weight models as you're bringing them into your enterprise, uh, before deployment, that sort of thing, new versions, etc.
I see. I see. And with that, thank you, Jason.
Thank you.